Uh-oh, battery low. Oh God!
What happened, Lakshmi?
I don't know, Rimsan. Something wrong here. I saw a spark.
Okay, you come here, Lakshmi. Let me check. It's gone, Lakshmi. You have to buy a new one.
Oh no, Rimsan. I can't buy a new one. I don't have money. Can't you do something with this charger?
Then let's try a reverse engineering with this charger.
Wow, that's great. That's very helpful.
Hi, I am Namal Bhattara.
Hi, I'm Ridwan.
Hi, I'm Nakshita. This is a 24-volt DC power supply from Shenzhen Electronic Corporation, and it is having an AC input voltage of 100 to 240 volts, which can be used all around the world. And it is having a frequency of 50 and 60 Hz. It can be used in both the frequencies. According to the manufacturing details, this charger is having overcurrent protection, over voltage protection, over power protection, and short circuit protection. And it is having a line regulation of 0.5% and load regulation of 5%. Its output adapter is a 3-pin connector, which is a triangular rectangle. It's having an efficiency of 80% minimum, and its rippling is less than 1%. And it's having a specific advantage, which is having a soft touch. And this is the best design charger ever.
Okay, let's see what's inside this charger.
This circuit is having 13 capacitors, 2 inductors, 16 resistors, 1 fuse, 1 multi-step transformer, 5 diodes, 1 Zener diode, 1 control IC, 1 bridge rectifier, 1 MOSFET, 1 optocoupler, and 1 triangular rectangle 3-pin pair head.
So, we have taken 2 snapshots of both sides.
So big, we have separated this into 3 parts. One is the rectification part, and the second part is the control and current driving part, and the third part is the output power rippling and the feedback part of the IC. So now let's look at the rectification part separately. So this is the earth, neutral, and power supply. Even though these two changes, it doesn't matter because of the bridge rectification. So here we are having a fuse which is 2 watts and 5 ohms. It is to control the overcurrent running in the circuit. And here this part is known as EMI filter, and it is also used to reduce the inrush current. This EMI filter, it prevents the harmonics produced by the circuit from entering to the AC power supply, and it goes through the bridge, and then it goes through the smoothing capacitor and it goes to the earth. The basic function of this is to prevent the overheating throughout the
Now
circuit.
let's look at the control and the current driving part of this transformer. Guys, in detail. This is the phototransistor part of the optocoupler. When the signal is received, the current will flow through this phototransistor to this feedback pin. When the feedback pin is enabled, the output device pin will be drive this power MOSFET and power MOSFET alternatively, and it has a predefined timing function also. So when power MOSFET is enabled, the current will flow through this circuit, this part of the coil, and it will sync. When it is off, the current will flow through this part and sync through this, and this will not exceed this breakdown voltage of Zener diode. By the time of this coil inducing, the upper coil will also induce, and this is called as snubber circuit. When this coil is induced, this Zener part will reverse bias. Then when it is off, the induced magnetic flux of this coil will generate a current through this coil in the same direction. This contribution will help to reduce the output ripple.
This part of the circuit does the output power rippling and feedback to the control IC. This C3 capacitor and L2 inductor are the energy saving devices. When any device draws current from the circuit, the C3 capacitor will start rippling. During this time, L2 buck inductor will produce the current and try to stabilize the voltage level. When the transformer off time, it will lead to the voltage drop across C13. In this time, the regulator IC will send the signal to the optocoupler, and it will lead to the switch on the control IC. In this time, the regulator IC will send the signal to the optocoupler, and it will lead to the switch on the control IC, and the loop will continue again over and over.